You need to readily act fast and put it out immediately. Thank you, sir. Make sure you have access to make sure that you access the cards and your equipment. You assess, sorry. Make sure you assess the cards and your equipment for damage. More like your leads, meter leads, and stuff like that. Either repair or discard equipment with exposed wires. So, and that is also relative to the vehicle that you're working on, because if you are on any system that uses high voltage, then we won't recommend that you do any repair. If you have anything exposed, then we would want to replace that to be sure that we are protecting ourselves. To make sure that we are protecting ourselves, right? So working with compromised equipment put you at risk for electrical injury. So some of those leads, when they get damaged, you just throw them away, toss them out. It's cheaper to buy a set of leads than to end up with serious electrical injury. All right, so these are some diagrams of exposure. All right. So in this is a fuse box, and you can see that this fuse here is broken, and then within the space also you see rust. There's a lot of rust, and that in terms will lead to high resistance, right? And in some cases you may lose contact intermittently or permanently for that matter, right? And here you have insulation damage, right? So these can be repaired depending on how much of a damage, because if you can look deep inside the crack, you can see that moisture is built up inside. You can see that moisture is built up inside, and this in essence will cause corrosion, and this will go through the system, and then you will end up with some amount of voltage drop. And some of these voltage drops are really unwanted, especially when it comes to activation of some components, some key components, right? So you have overheating, melting across the connection, right? So it could be as a result of slack connection that cause that also. That will can cause the temperature to rise, and it will cause the insulation to melt up and burn, right? And then there is a broken connector, so we don't want to do any repairs to this. We want to get rid of that and get new fitting in to ensure your safety, one, the safety of the vehicle, and the customer. And I'm pretty much sure that some of these you would have already been through and be aware of, but we still have to reiterate them. So every time we meet, we're going to be talking on that basic same principle: safety, 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 the importance of safety. Okay, so we're going to talk about some basic electrical principles now. Voltage is defined as the energy required to move a charge between 2 points in a circuit. Voltage is the difference in electrical potential between 2 points. Basic unit of voltage is volt. denoted as volts, is defined as the electrical potential between 2 points of a conducting wire when an electrical current of 1 ampere dissipates and watt of power between those points. Okay, so this is an illustration, a pictorial view to give you an idea of the voltage as pressure and the current flow. All right, so here we have the pressure is restricted by a controlling device. So the pressure is present, but there is no flow. So we have the pressure here constant, but in order to get this flow, we have to break a seal, open a contact or close a contact for the continuous part of current to flow. All right, so here you can see we release the valve and the pressure begin to flow. All right. So this is similar to a water system. All right, so current. A stream of charged particles, such as electron or ion, travels through the electrical conductor, or vacuum is known as electric current. It is the net rate of electric charge flowing through the to a surface or into a control volume. It describes how much charge travels past certain points in a circuit over a specific period of time. Okay, so here we have a basic electrical circuit. So we can identify some components within this circuit. So here we have our source, right? And this would be our conductor, the electrical wires. And here we have a controlling device, which is a switch. And of course, we have a load, right? Then we have to come back around and ground it now to complete the loop. So we have to complete the loop for electron to flow, right? So this controlling device in itself, it could be anywhere in the circuit, right? So we could control the positive side, or we could control the negative side. If you notice how this wire is routed, it's if you were to have this connected here and this connected here in the circuit, right? For automotive, because it's just a regular load, it still would work. In some other cases, it would not work. You could actually create a short circuit depending on how it is constructed. The circuit is constructed. All right, but for this diagram, it works. All right, so if everybody is clear on that, we'll move on. Is there any question on the diagram? No question on the diagram, so everybody's okay with that.
Yes, sir.
Okay, so yeah, I'm back at the diagram. Everybody's okay with the diagram. So we identify our source, right? We identify our insulation, and we identify our main element and our frame. Right? So when you begin to do any form of electrical check for operation, these are important part of the circuit to ensure that you check and verify. So if you have to write it down, please do. So you must check for what? Source. You must check for source. Your main element, which is what you load. Right? Your insulation and your frame. All right. All right. So resistance oppose. Resistance is the opposition offered by the conductor to the flow of electron. That is to current. No, make him go on, let him go on. That is to current. Electrical conductor have low resistance. Electrical insulator have high resistance. Semiconductor have resistance more than conductor, but less than insulator. So here we have a diagram. So we have the voltage, which is pressure. And of course, we can see that we have reduced the space between the points, so that in itself offers some amount of resistance. Now, here's the current trying to go through that tiny space. So this was the space originally where we have the pressure, the voltage pressure. And here we have reducing that space. So the reduction of that space now creates some resistance. And we are trying to push this current now through this resistance, right? So resistance oppose current flow. So if for argument's sake, we have constant voltage here, whatever the voltage is, but we have voltage constant, right? And if we change this resistance, right? If we change this resistance, right? Let's say we have to pull this rope tighter, we would have to apply more. That would mean that you take a greater amount of current, amount of pressure to get this current flowing. You understand?
So, sir, you're saying the ohms is actually resistance.
Yes, so resistance is measured into the unit of resistance is measured in ohms.
So the lesser the ohms is more resistance, or is it that the more the ohms?
All right, remember this. In principle, resistance opposes current flow. So the greater the resistance is the less current will flow. You get that?
Yes, sir.
All right, so we just want to, once you have that principle, then you will know that the resistance is there. Then in some cases, you will have resistance that are calculated. And that's fine, because it's calculated, then whatever is controlling the current flow, right, knows how much current to apply for that operation, right? But here we are with a calculated resistance as this is, right? But now we are going to add some more resistance, right? So because the resistance is so high, it's oppose this current flow, because this is unwanted. So this that is supposed to be pushing the current is unable to push it, right? Because it's not built to push it, because because this resistance is already calculated and is taken care of. So now that we increase the resistance, then we'd have to try to increase this, give this guy more strength to push the current through, right? So if we loosen the rope, then we'd have what? Less resistance. And then we'd have greater current flow. So one of the ways we can increase resistance is through insulation. So let's say, for instance, this wire was a 14 gauge, and we put an 18 gauge wire, we could increase the resistance by that. Right? That's one method of increasing the resistance. Right? Or you could add in an additional load within the circuit. That would create some amount of resistance also. Right? Now, if we create the resistance, then we have to do something to ensure that we can push the current. The important thing is that we have current flow. Clear?
Yes, sir.
All right, good. So Ohm's law states that voltage across a conductor is directly proportional to the current flowing through it, provided all physical condition and temperature maintain constant. All right, so here is the critical element in this information. It is the temperature, right? If we can control, so if everything physical is okay, right? And we can control the temperature, then we are better able to control what? The flow of current. Because temperature changes affects current flow. And once we deal with the current, our biggest concern is temperature, right? So we must control that temperature, keep it at a recommended temperature, so as we have proper function of the components within the circuit. So Ohm's law equation says that voltage equal current times resistance, whereas V is voltage across the conductor, I is current flowing through the conductor, and resistance, and R is for resistance provided by the conductor to current flow in the circuit. So this is the equation, right? So if you know any one of these or any two, then you should be able to find the other. For instance, so if you know voltage, right, and you know current, then you can find resistance, right? If you know resistance and you know voltage, then you can find current, right? And if you know current and voltage, then you still know resistance over there. So V equals current times resistance, R equals voltage divided by current, and current equals voltage divided by resistance. And probably later down in the class, we will do some exercise as it relates to that. Okay, these symbols are poorly erected. Okay, so we can see some electrical parameters, the measuring unit and their symbols. And their symbols. So voltage is measured into units of volts. And the symbols is either V or E. Right? Resistance is measured into ohms, and it's either I or the sign for ohms. This is a farad. Capacitance is measured into farad, and the symbol is C. And charge, what is this? Is measured into coulomb, and the unit is Q. Right? And so on. These are giving me I8. So understanding wiring diagram. So a lot of persons find a big challenge in reading wiring diagrams effectively. So wiring diagram is pretty much like a common road map, right? If you travel on the roads from one point to the other, then you would have known the route of travel, and then you will have some road signs, right? And you will, along those signs, you will have some do's and some don'ts, right? Because if we do not pay attention to these, then we could end up with fatality. That's on the road. So wiring diagram and road maps have much in common. Road maps illustrate how to get from point A to point B. Similarly, when you travel on the road. However, instead of connecting interstate highway and roads, wiring diagrams show major electrical systems such as system, subsystem, and individual circuits, all interconnected. Every electrical circuit on an automobile has three things to operate. And of course, some of these you would have already known from earlier. We must know where our source is. We must know where we get our source. We must know in terms of pressure, how much in numbers our source is. So if you're working on a vehicle and you don't know the source, it's important for you to check it first. Because if you use the wrong equipment and the wrong source, then the equipment will be damaged. And then you can also be exposed to electrical shock. Right, so you must know your source, right? Battery function as power source. You must know your loading device. So you remember that simple circuit that we have been through this. You must know your source, you must know your load, which is your main element, and you must know your ground, which is your frame. And also, you must never check those and not check your insulations. Very, very important. So as it comes to electrics, right? If we are in this class, in this session, you will hear we use terms like source, your main element, your frame, and your insulation. So I want you to be get familiarized with these terms, because going forward, that's how we check. That's how we do dynamic checks, right? Static test is kind of a little bit different, but that's how we do dynamic checks. You must verify your source. You must, I say, a battery source. You must verify that. You must verify your loading device, right? Anything does electrical work is your loading device after current is flowing through, after current is commanded for the circuit. Ground return, the completes the electrical part. So without a ground, you don't have that closed loop. And for a current electron to flow, the loop has to be closed, right? So the electrical part from the battery positive to the end of the loading device back to the battery negative terminal. That's how your loop is created. Loading device must be controlled. Why we want to control our loading device? Why do we want to control our loading device? Anybody remember? Hello?
The switch on and off.
No, we
Because of the
must
temperature.
control. Exactly. The only way we can control temperature, we must be able to control our loading device. Whatever means of control you have, we must be able to control that temperature. Right? So we control the loading device to maintain a temperature, a specific temperature. Right? Some loading device are switches on and off by controlling their power source, while other controlled by switching ground return on and off. So remember now I was on the diagram I was showing you. Let me see if I can get back to that diagram quickly. I was showing you, okay, so we could have the switch here. Give me a minute there. Can't find the mouse. Okay, so the switch here, it's controlling what side of the circuit? It's controlling the power side of the circuit, the hot side, right? So we have voltage here, we have our source here. Mouse down again. Yeah, right? So we have our source here, right? But we are controlling the positive side in this diagram. While we could be still control the same circuit, but we control it from this side also. Because what the switch does, it just open the circuit, right? So the switch is a normally open switch. And when you flick the switch in the opposite way, it becomes closed. So it causes the contact to meet and electron begins to flow. So we could control it from either the positive side or the negative side. Is that right? Okay, good. All right, so the ground return completes the electrical path from positive to negative, from the battery terminal positive to the loading device back to the battery negative terminal. Right? And we now begin to control that load. We must control that load in order to maintain the temperature. And we control that load device through what? A switch. Right? So it's an on and off switch controlled either by the power source or by the ground. The most common scenario in using vehicle electronic control unit, short ECU, to ground relay that in turn control the load. Right? So yeah, so the load, so the relay now becomes a what? A protector for the circuit to help to maintain that temperature, to keep the current, to keep the temperature down. Right? So we use the computer now to control the relay, right, to maintain that temperature. So, and in some application, however, you will have the computer controlling the positive side. So in that case, what you would have is a fixed ground. Upon application, the computer will supply a 12 volts to the solenoid or relay to control the current flow, control the circuit, and to keep the temperature down. The process of figuring out how load device is controlled and its powered and ground, and its power and ground source can be determined by using wiring diagram. So this is where the information, so each road you pass, there's a road sign, right? So with the road sign, I will tell you where that road will take you to if you were to be looking at on a road map. So if you're on the physical road, you might not be able to see why, but on the road map itself, you could join, you could make the connection which road carry where, and where you're going. If you take one turn, that's on a left turn, that's where you will end up. So just like with the wiring diagram, you're going to give us some information as to how to locate some key operating components and where and their location. For instance, if you have ground points, right, it will direct you to where each ground on the vehicle and what the ground is, what the ground control, or what is grounded rather, and the points and where to locate and its location. of course, you will also be given the information on the color wire or wires that is used in each application. All right? So electrical symbols. An electrical symbol is a graphical representation used to represent electrical components or devices in schematics diagram or circuit diagrams. These symbols are standardized and universally recognized, making it easier for engineers, technician, and electrician to use and to understand and interpret electrical plans. So that is just like a roadmap. So if you are able to successfully go through the map, go through the diagram with understanding, go through the map with understanding, you will realize it's pretty much the same. So if you miss any information, then you will be you will be cast aside, and then you'll be in confusion. But we are going to have some of those as exercise further in the class. Also, so we are just going through the preliminaries right now. So, any question thus far? Okay, so we can move on. Okay, so here we are looking at some symbols, names, and their description. So, first on our list, okay, this represents electric wire. It is a symbol that is used to represent a wire. Right, so if you are to get a diagram and you see this, you know it's speaking about a wire. Right? This is telling that the wire is connected. And you can see the dots. What am I doing right? Go back up. Sorry. And you can see the dots. The dots shows you that you have two connections. So it's two different connections. You have a connection here, you have a connection there. Right? So the symbols represent wire connected across, and the symbols indicate that there is no connection. Why am I mouse? My mouse busy around the panel. Okay. I want to work touch screen, so I don't know about this. All right, so yeah, so this represents that there's no connection at the cross across the wires. So this, if you are looking, it's the same wire, but now we are connected with two dots on the same wire. We have the same wire, but we have a connection that loops over the wire. Right? So this really actually loops over the wire. You understand? So here we have now some symbols for switches. Right? And this symbol is for a toggle switch. Right? Okay, so this symbol is for a switch that disconnects current when it's open. Right? So this would be a normally open switch. So if you want current to flow, then you would then now put the switch in closed position for current to flow. For current to flow. Right? This is also a toggle switch. Right? But this switch now selects between two connections. So you could have on one side of the switch could be a control, and on the next side it could be another control. So you could actually use this as a switching. This probably couldn't do switching polarity. I don't think this could be as a switching polarity, but you could have two different functions with this, because here you are on, and here you could turn off the circuit. So if this is the part to the circuit that is flowing, and you want to interpret the circuit, then you flick the switch this way. Now you have no continuous part now. Right? Like here, there's no continuous part, there's a continuous part. So it depends on what the function of the switch is. And of course, down the bottom here, we have a push button switch, right? This is a symbol that denotes momentary switch. So it's a momentary switch, right? And it's normally open also. So this in this application will be something like what you're on. You understand? You want to press your on, or in some application they use them for alarm purposes, kill switch and stuff like that. All right, so electronic symbol circuit. So our first up, and of course you guys might be aware of some of these already. We have here a resistor, right? So this would be just any resistance in any circuit. It could be a resistor in a potentiometer, a throttle position sensor, something of that sort, right? Or analog airflow meter. You understand? Or you could have a circuit design with a relay, right? With a resistor inside it. You understand? Now this is a variable resistor. No, this would be the potentiometer. The variable resistor would be the potentiometer. Yeah, so sorry about that. This wouldn't be the potentiometer. This resistor would be the potentiometer. This resistor would be the in the potentiometer. It's a variable resistor. It also, you will find that also in your fuel gauge unit, tank unit. This one is not it. This one is the variable resistor. All right, so you have a light dependent resistor. You have a non-polarized capacitor, a polarized capacitor. You have a diode, a lighting emitting diode, a Zener diode. You have an inductor, and we know the switch, the symbol for switch already. All right, and going forward, we want to pay attention to this because whenever if we're doing any block diagram with a source, this is how it will look. So you will have the positive side and the negative side, and this is telling you that is your source. And this is per cell, right? And of course, that's DC. So you have DC voltage, and this is the source voltage, again, your positive and your negative. And depending on the diagram that you are looking at, you might either see this or this. And this is also another voltage source, but this is not direct current. This is alternating current. And of course, this is what your symbol for your bulb will look like. And this is what your motor will look like. And your transistor, whether it's PNP or NPN. So the difference in the resistor is that there's a diode, that current is going one way, and then this side is going the other way. All right, so you have a speaker, your buzzer, the bell, and your transformer. And you will see this in diagram as anything to do with coil or electrical induction. So this will be your coil, and this is your antenna, and of course this would be what your ground circuit looks like. So we have to remember also that when it comes to makers across the world, while this might be standard for some, it might vary in other era or with other manufacturers. So we have to be mindful of that also. So here are some other symbols, electrical symbols. So we have, of course, here we have a diode. This is a blocking diode. And we have a capacitor. Here we have an inductor again. Capacitor. Pretty much going back to the same thing. Yeah, AC volts, DC volts. And these are for like diode and cathode and them things for more intense electronic works. These are for more electronics work. Electronic works. Where you have your AND gate, your NAND gate, your OR gate, your NOR gate, and all the other gates. You have inverter. So this is your symbol for your coil. And this is your light emitting diode, which is in short LED. And this is your standardized transistor and your fuse, your transformer here again, and this is your regulator. And this, yeah, and this is your regulator. Yeah, so these are just some symbols that left to what you're doing. Some of these might be more important to note more than some, because if you're into high-tech electronics, then you would definitely have to know about the different gates, transistors, capacitors, and all them things. Even the diodes, what they do, or the current flow, or the black current, or the allow the path current, and so forth. So these are some insulated tools for protection, right? And as we said, if any of these get damaged and you lose the installation, please get rid of them. Right, so here we have our speed blade screwdriver. We have our star, which is commonly known as Phillips and flat. We have your cutting pliers. Here, your side cutter. Some people would call that nipper. Yeah. And this is your wire stripper. So also on your wire stripper is your wire gauge, and you have a cutter on it also. So you can use this to gauge your wires, right? And it's, of course, it will have numeric value on it. Now, here we are with our personal protective equipment. And we have here is our liner. That looks like a liner, yeah. Here's our liner, and this is our insulated glove. This is your liner, your insulated gloves, and your outer glove to protect the insulated glove. So, of course, you would have remembered from previous class the purpose of each of these. And you have your eye shield, your protector, your category 3 multimeter, and of course, we cannot rule out our high voltage warning sign. And this here is your hook in case you have a colleague that is in trouble and you are able to render assistance and protect yourself in doing so. And this is the insulated floor mat. And of course, we have a protector for the gloves. Okay, so this is your digital multimeter, one of the famous, more expensive, high quality, car mashup multimeter. I have had these like for years, 20 odd years. If I were to buy any of these now, probably I couldn't afford it. You understand? So this is a digital multimeter, also known as a DVOM, digital ohm voltmeter. So you can use it to check resistance. You could check voltage, both AC and DC, right? You could check resistance. You could check, well, that comes under that. You could check amperage and milliamp. You could check frequency, duty cycle, right? And of course, it's also, this one is a good one because I think there's a backlight on it also. Right, so you have to ensure that whenever you are doing certain jobs, then you have the equipment to do the job. This meter should has a 10 mega ohms impedance, which means it's safe to work around any control module that you may have to be testing. All right, so of course I'm not telling you to go and buy this expensive one. I know it's very expensive, but you need to familiarize yourself with how a multimeter function. Very, very important, because numbers is everything. So if you develop the art of studying numbers as it relates to mechanical or electrical application, then it could help you tremendously. All right, so if you were to see a voltage value on a particular component, then you will be able to have a good guess of what's happening mechanically or electrically. So this is a very good start of a diagnostic. That's where we, the good guys, that's where they started. We didn't have a fancy scan tool or any oscilloscope or those things. Right, so we have to make good with our vacuum gauge and our multimeter. So vacuum gauge is also a very good tool to have, very handy. Okay, so here we are now putting our meter, our DVOM, our digital multimeter, to work, right? So we pay good money for this, so we have to use it to make back some of the money, right? So when a mechanical aspect of your vehicle isn't working properly, there is no way, there's not always a direct apparent reason why. To identify the electrical issue, you will need to use a multimeter to see whether or not voltage and continuity are present in your vehicle's wiring. All right, so basically what we are doing here is to check our controlling device. What we are doing is checking our is doing the boss there? Yeah, we're checking our controlling device and we're checking the power source and them to ensure that none of them are broken, so that we ensuring that we have a continuous path and our electrical circuits. Depending upon what unit you are looking to measure, you will want to set the range. Yo, remember we in a class in the bus stop? Depending on what unit you are looking to measure, you will want to set the range and parameter for your multimeter. Right? So you need to have a basic idea of the voltage value within the circuit, so you can set your range and also your parameter to be effective in your diagnosis. If you are going to test for amperage, make sure to always use the fuse port for your probe. Otherwise, you can use the non-fuse port when looking at your probe or your leads. The black one is the negative and the red one is the positive. Of course, that you would have known. Okay, so this is a very important piece of tool. When used properly, it can cut all your work in half or less if you know to use this effectively. Because you can use this to do some of the tests that your multimeter, your DVOM can do and more. Some of these have voltage variation at the pulse point, which means that you could use them to do simulations. This one doesn't look like one of that. This is just a standard one. All right, but nonetheless, very, very effective if you want to power up a circuit or you want to send ground to a circuit. And to be sure that it's protected, this is the tool for the job. However, never ever use this tool in and around where the engine control module or any other module for that fact, right? Because it's easy to accidentally send unwanted power or unwanted ground to a circuit. Then you will have to pay for loss of use of vehicle plus buying back modules for a vehicle that you don't own. So you must be very, very careful when using this tool. When using this tool. Okay, so see you have the extended lead, and I'm pretty sure this has both 12 and 24 volts. So you can use it for both source application. All right, so power probe basic is your best value for testing automotive electrical problem. Upon connecting the instrument to the vehicle battery, you can detect if circuit is positive or negative or open. So you can also use the check continuity. That's what it's pretty much saying. You can do this by probing and observing the green and the red LED lighting there. So on the tip, let me show you something. Okay, so on this right here, where you have this insulator, is an alligator clip, a small alligator clip, and that's a ground source. So once you connect this power and ground, at this point here, you have a ground, and this point here is an application where you can send 12 volts. So you have a physical ground here, but you can also send power by pushing the switch forward and pushing the switch backward is ground. And of course, here you have a button to press if you want to. Let's say you're not here where you cannot see, but you can hear. So when you make the connection, you know if power or ground is there. All right. So let's say you're in one area where the starter there way up and you can't see, but you can get to the back of the wire that connects to the solenoid. And you have somebody crank the engine because the starter is inoperative, and you have somebody crank the engine. And if you press this little button now, So it gives you one sound for positive and give you a different sound for negative. So if 12 volts, sorry, if 12 volts come into the circuit, you get one sound. If ground come to the circuit, you get another sound. So, like I said, it's just to get familiar with the tool. It's a boss piece of tool. It's good for every technician to have one of these. Right? When you have one of these, then you have bragging rights. So logic probe are used to analyze the logic states, which is high, true, logic 1, or low, false, logic 0, or digital signal. To verify the debug today's high speed, low voltage digital signal, you need logic probe that can correctly acquire signal from a wide variety of electronic designs. Okay, so this is another one. Never seen this one before. This looks like a LED. So this is the one that is safe to use around the area of the computer, because at the tip of this is less than 12 volts. Right? So it's not pretty much a volt, it's an amperage. Right? So pretty much what you see is what's coming out from the circuit. So the red will indicate yes, a positive, and the green indicates a negative. So you could use this to check if you have a pulse at the crank sensor, cam sensor. You could also check if you have control over any one of the output, whether it be idle speed control, whether it be injectors, solenoids for the transmission, ignition coil, and so forth. Right? So it's a switching between red and green. So if we were to think about duty cycle, I remember now that duty cycle is a percentage of total time. So from point A to point B is 100, and in between is a percentage of. So that's duty cycle. So if, for instance, red and green, if you remember from primary school, red and green gives you what? Orange. Right? So if it's pulsing fast enough and you're seeing orange somewhere, it more tell you that you're about 50%. If you have more green than red, it tells you something. If you have more red than green, it also tells you something. Right? But we're not going by that. We need numbers. But it's just if that's all you have at the moment to do with the test, you can make a good guess. So the LED test light is a small consumer, 0.025 amps. As we said, that is safe to use at the computer because the amperage is low on it. And it's safe to test in a circuit of electronic device. Often these test lights have two diodes, LEDs, of different colors. In addition to measuring DC forces, also provide information on the polarity of the measuring point. All right, so if you were to connect the black lead to the negative battery and the red lead to the positive battery, and you use the point, of the LED to put on the positive battery terminal, then you will get, it will light red. And if you were to put that on the negative battery terminal, then it would light up green. All right. Okay, this is just a regular 12-volt test light. All right, so if you notice inside, this is just the contact spring, a bulb and the point, and one wire with a pigtail. So this is also good to have for some application, because if you want to check some circuits and you're not sure of the amperage, then you could use this tool to create what actually create a voltage drop. So you would add this as a load and it will drop the voltage within the circuit. So you could also use that to simulate some conditions. But I wouldn't advise you to go high-tech with it. So this is for some on some vehicles just for lighting. And let's say, for instance, you want to know some voltage, some circuit will have a low 12 volts, while some have a high 12 volts. So this is a good tool to tell you whether it's a high 12 volts or a low 12 volts. So if you check and the voltage is 12 volts and you use some put in there and it goes dimmed, that tells me that it's a low 12 volts. And you find that most find those on like highlight circuits. Right? So yeah, not because you get high-tech, don't throw it out. It's very handy. Also known as circuit tester or test lamp, it can check the presence of absence of electricity in circuit. Easy to use, this tool gives quick results than digital multimeter. Because one of the reasons that by the time you put the meter on it, it has to read through before you actually get the voltage. So if you're using the multimeter to do the test that you would normally use the voltmeter, the regular 12 volt tester to do, then you will have to exercise some patience. Right? And you have to be very, very careful to make sure you have the proper connection. The thing with that, when you use a multimeter, nothing can hide from it. In that, you could use a 12 volt tester or a LED for that matter in a circuit and it lights up. But when it lights up, you do not know the amount of voltage that is present. So you really don't know your source. Right? And believe you me, that will show you a way. Because it did it to me, and I'm sure that it did it to a lot of persons. Right? Sometimes even checking a common fuse, it will read that the fuse is good. And if you're never to use a multimeter to check the fuse, then you still end up in a problem because you're searching for the problem and it's right in front of you, can't see. So you're chasing a ghost. So I still stand on the premise that the multimeter, if you can use the multimeter effectively, then you become a better technician. Notwithstanding that all of these tools have them advantages and disadvantages. So you have all of them, but when it comes to certain things, when you're looking for a particular problem, you need numbers. Numbers are everything. Are we clear?
Yes, sir.
All right, good. So may I encourage you now to just invest in one little multimeter. You don't have to buy the expensive one. Because like I said, some of these are pretty expensive. OTC is a good brand, not as expensive as Fluke, but it's still a good brand. Right?
They run about $7,000 here in Montego Bay.
For the OTC?
I believe so.
Yes. And that's not a bad investment to start with. You understand? So practice, we must, whenever we learn something, we must practice it. Because if we don't practice it, then we lose it. Not only that, but when we practice it and we get familiarized and we get familiar with it and we start to learn, it gives us power, self-gratification. We want to learn more, we want to do more, we want to become researchers. And that must be your objective. Right? You want to develop the art of researching. Right? So you can own your craft, you can perfect your craft. So you can use the test light to check any positive and negative circuit. If a component is showing problem, but the fuse seems fine, this tester can trace the circuit, trace the wiring route to pinpoint the source of the trouble. All right, fine. So remember what I said now. While you're using this, don't depend on it alone. Right? The numbers means more. Because remember now, We have a small amount of resistance. We have a resistance that we know that we cater for. It's built in, so we know this resistance. So when we see this resistance, we know what to do. Right? Over time, with temperature changes, insulation becomes get broken down, wires start to crack, moisture start to creep in between the insulation and the wires. It start build up corrosion, resistance start to increase. Now, remember it's a light, you know. It takes less current to illuminate the light, right? But to do the work that you need it to do, you need to ensure that you have what? Good source. You need to be sure that your source is good. If your source is good, and you're sure that your source is good, then you're not looking for the source of your problem. You're looking for your problem elsewhere. You're looking for your problem elsewhere. So if you don't know, you need to know so that you don't waste time. Right? Because if you're going back and forward because you're not sure, you're switching component and you're not making a check, you're not making reference. So the thing to do is to get numbers, then you can switch a component. When you switch a component, if the number change, it tells you something. If the number remains, it tells you something. Now you have to analyze the situation, right? And put on your thinking cap. This is where your analytical troubleshooting comes in. You understand? Okay, so here we have pretty much introduction to the wiring diagram. All right, so let's see if I can go through this. I did another diagram. Might have to do that for the next class because this one, the information on this is not very, very good. So I am going to skip through this. But if you don't see me go back to it, please do remind me, right? That we need to go back through that introduction of electrical wiring diagram. Right? There's another one that we had found, but we didn't get a chance to put it up. This one is pretty much big. And in that and it's not carrying not giving enough information for the roadmap. Okay, so I think this would be coming from that diagram. If we were to look there, let's go back here, where it give you letters. Yeah. So you have A, and A says introduction, and B now tell you what? System circuit. C gives you the location and routing. D is for your fuse listing. All right. And E is for your connector list. And this is for your overall electrical wiring diagram. And the short for that is EWD. So when we come over on this page now, and we can see we're going through now. So we have pretty much the same the introduction. So this is what the breakdown will look like. So on the page, it will walk you through here, right? It gives you the introduction, how to use the manual. It gives you a guide to troubleshooting. It gives you an abbreviation for acronyms for words. It will break it down. And it also gives you the glossary. You have the relay location, wire diagram routing, power source, current flow, system circuit, ground points, and overall wiring diagram. And we'll definitely have to go through those bits, bit by bit. Right? Every wiring diagram shows only one system at a time. The parallel connection to other circuit can be traced using power source, ground points section. Tracing current flow through the circuit is also easier because the power is at the top and the ground is at the bottom. So if you were to look at the diagram and you're looking for power, please don't go down the bottom, go look for it. You understand? You'll be wasting time because you get the information. So anything to do with power, power source, look at the top. The ground point will be at the bottom. All right, so there we go again, back to the flow with the introduction, circuit, system circuit, location routing, and all of that. Okay, so best, I want this diagram to be a little bigger, so we can put some practice. So if we remember, when we talk about, well, the first thing we got on the A, we talk about A is what? No, that would be a system circuit, but this fuse is D, but over here say to give me something different. All right, so anyways, so that would be this here would be what? Remember I say you're looking for power, you look up the top, right? You're looking for ground, you look down here. So you never find power down here unless something really drop down wrongly. So right here is what? It's our source, right?
Look like a fuse.
Exactly, right? So we have to protect. In that source, we must protect. We must have a protection in case we end up with some condition that causes us to be going down to ground to short. They will take the fuse out and then we protect the rest of the circuit. All right? So that in itself is our source, right? Outside of our source is one connection here, and there's another connection here, right? But there's also a bypass to both connections. So where you have that green, where you have this is a bypass for both connections, right? And this actually could do with manufacturer's discretion, right? So this may have to go through some other device before it gets to that point. It could be a junction, and it could have a splice off or a split, right? Now here is this relay. Oh shucks. I don't something trouble. So here is this relay, right? So now let's look at the relay and let's practice some of what we learned earlier. All right, so at the relay, we must have a source, right? So with this source, the source came from what? The source came from the fuse to this point here. Oh, sorry. The source came from the fuse to this point, right? So we have a connection right there. Now, on the other side of the relay, where the coil is, on the side of the relay where the coil is, right? We have a control, right? So we can recognize now that we have a fixed ground at the lower corner here that goes all the way to the relay, yeah? So if we were to apply 12 volts to this, right? We create a magnetic field that will close this contact, and whatever we have here as our source, then we will send it to this component, right? Which is a motor. Right there? So there again we go we confirm our source and we control our we confirm our source and we confirm our frame, right? So this source is coming from what? The ignition switch, right? This source comes from the ignition switch to the relay. We confirm a 12 volts, we confirm a ground. So if we confirm a ground and we have a 12 volts here, this should close. And if this should close, and if this is closed, then what we should have here? 12 volts. Ain't it? Hello?
Yes, sir. Yes, sir.
All right. So if we don't get 12 volts there, so, and we're sure that we have ground, and we're sure that we have our source, and we're sure that we have our input, then what it tells me? That this not good. Ain't it? Because
Yes,
we're
sir.
sure we have this, you know. And we're sure we have this, and we're sure we have this. But we're not getting this. That can only be that we have poor electrical contact within the relay. Right? So
Yes.
if we notice now, this is in series with the rest of the circuit. The relay is in the series within the series of the rest of the circuit. So if for instance there's a problem in any circuit and you can find the relay for that circuit, then it's much easier to execute the test right there. Because you'll take out a lot of time. Why? Because you're checking the circuit from the middle of the circuit. When you check the problem from the middle of the circuit, it tells you whether the problem is upstairs or downstairs. Eh? Quick time, done.
Yes, sir.
All right, so if we get to the middle, and we take this out of the equation and we make sure we have everything, then quick time we can find where the problem is. We don't waste no time. And one of the things that you can use to also check this out of the circuit is your DVOM and your amp probe. So what you would do with the DVOM, you would put the meter on ohms and you press continuity and you'll go across the source and the output because that's your contact point, yeah? And then now you will apply a ground here with your probe. Remember the little pigtail? It has the ground. And then you will add power to the input that's coming from the ignition switch. So you will add power here and you will add ground there. And then if you have proper contact within the relay, then you will hear the multimeter give you the buzz to confirm that you have continuity. Of course, we'll have to probably do some practical with some of these tests that we are, I don't know how much experience you have within that. All right, so this is just one easy way to always check any electrical component. Find the middle part, find where the control device is, and run the check of the control device. Ensure that you have what? Your source, your frame, right? This now would be what? Your main element, right? And you have your output, and this would be your input, right? So if you have that, quick time you're done, run the check, and you can tell the customer what needs to be done, and you go. Just a minute. Yo. Yeah, man, anyway, come in, I want to ask me to talk about it. All right, so that's pretty much part of it. So now for the rest of the circuit, there are other information. All right, Mr. Bess, is there any way we can get this up a little more? And we want a little bigger? Yeah, yeah. All right, yeah. All right, you seeing this now?
Yes.
Okay, so we can see a little clearer. Right, so if we are to look over here now, so we have some other, here are some other controlling device. So you see, this is another controlling device. And we use this device to what? Control what? Temperature within the circuit, to control current. You understand? So, of course, this is also fuse. And this can't say what it is, but it looks pretty much like it's pretty much looks like a junction box.
Or ECU.
Or a junction box. If I could get that up big. It could be an ECU based on what I'm seeing there, the diagram inside it. But this probably look more like, since it's controlling the power, you notice it's power in everything, it could be coming from the BCM, body control module. But it's a controlling device. You understand? It's the mother of the nation. It protects the children. All right, so A is the fuse. Yeah, we had thing there. So pretty much going back to what we did earlier. Indicate the name and capacity of the fuse. So you will have in the fuse box or the diagram itself, you will have a fuse that says EFI, electronic fuel injector. You will have injectors. So name and the fuse capacitor in terms of like amperage, ampere ratings. Right? You'll have your power source system indication, and it indicates the ignition key position, which could be either ignition 1 and ignition 2, or you ever see another? Mostly like ignition 1 or ignition 2. Yeah, so ignition 1 would apply for certain condition, and ignition 2 will apply for another condition. Outside of accessory, you could have 2 ignitions. Are you looking for papers? You don't need, you don't need that. Why would you look it up? Yeah, exactly. Yeah, just make sure you know speed. You know speed. All right. So, and on the diagram, as I said before, depending on where the vehicle is manufactured and the information received, you will have some of them just giving like numbers, like vehicles out of Europe for at all the time, which is battery. That would give you on the wiring diagram, you will see 30. And if it's from an ignition source, you will see 15. All right. Okay. You understand? While vehicle from pretty much everywhere else around the world outside of Europe, you will have straightforward information like battery positive or 12 volts, or they give you that information. But European wiring diagram is pretty much, it pretty much differs, and you have to really study it. And even as it comes to color coding, it's not straightforward. But we're not going to get into that part of it now. We just want to focus on the simpler things so that we can resonate well with it and we can have an understanding. Then we can go to the more complex things. All right, so C specification is used to indicate different connectors, wires, wiring colors, etc. when the vehicle model, engine type, specification, etc. are different. All right, so just like I was saying before, it depends on where the vehicle made, where the vehicle for the market is made for. Then you may have a variation with these specific information. All right, so up top here, you know, we have the information at the very, very top, and it says, it says, I say, without start and stop. So /O means without, and if it's going to ask you if it would have with, so you would either see with or without, and it's want to know if the vehicle is equipped with start and stop or not. So you have to be aware of that to know if it does have that or not. And the thing is that, all right, and the thing with that is that in some instances they are optional, and a lot of vehicles they are not, because if it's left to you, makers realize that you don't want to protect the environment and for us to live a little longer. So makers is doing everything to ensure that we stay alive a little longer to sip up some of the milk and on the down. All right, so wire color indicates the wiring color. The wiring color are indicated by alphabetical code. All right, so color wiring, general wiring, for example, L slash Y is indicated as a color for blue with yellow stripe. All right, so in that case, you could have some wording like BLU, and then you will have YEL. All right. Now you could have wires with bands. You could have wires with silver bands, more than one silver band, 1, 2, 3. You could have wires with red bands, more than 1, 2, 3. Okay, so for the band, it will be like how you have the blue with yellow stripe, and you may have more wires within the system with blue with yellow stripe. So what they do, they add a ring around it, around the wire, and they have space between them, right? And if you have, like, say, 2 inches space, 2 inches space, 3 inches space, whatever the case may be, that would be now blue with yellow stripe with 1 silver band that is designated to a point. You may have the same blue with yellow with double silver band that has a different designation, right? So, and then you have to be very, very careful or you read it too, because you must not confuse yellow with blue. So when blue comes first, that means you have more blue than yellow. So whatever color comes first, it's the dominant color. All right? So some makers will spell it out BLU with yellow, right? So if anyways, we're not going into that. So so here we have the color, right? The color information. So B is for black, L is for blue, R is for red, B is for pink, O for orange, white is for W, V is for violet, G is for green and yellow, and BE is for beige, and BR is for brown. Okay, so SB is for sky blue. In some vehicle, they will say light. Okay, so LG is for light green. And then you have gray and you have dark gray. So DG would be for dark gray. So it's just information. Different makers use different things and different arrangements. So don't be confused by it. It's just for you to remember, get as much information that you can get, because when you look at the different diagrams and you go into the section that tells you how to use the diagram, you will get all this information from there. So when you open the page and you at the top of the page, you will have your introduction. Then you see they will tell you if you want, they will ask if you want just the diagram or you want to know how to use the diagram. Right? So until you become proficient, just let them show you how to use the diagram. They will show you how to connect wires, they will show you bad wires, good wires, how to determine, how to clean wires before making contact, how to solder, how to wrap wires and stuff like that. You understand? Diagram information. So when you know all of that now, then you begin to use what you learn for the wiring diagram itself. You understand? So collect as much information as you can get before you actually go to the vehicle. Right? So of course you're going to go to the vehicle and run your preliminary checks and all that. See where you find where you're not getting. But when you go to the wiring diagram, you don't want to be like back and forth. So if you have to print documents or you have to make a jotting or something, just collect the information before you go back to the vehicle. That's when you go back to the vehicle, you know what you're going to do. All right, so remember now I was telling about the different band. So they're called them painted wires. So you have black, these are black bands, and you have red bands. You understand? So this one you have double band. So you have 1, 2, and 3. So here you have single bands, and this here you have double bands. So these are indicators for different designations. So if these wire go one place, please don't put this where that go. Pay attention to the bands and try to get them where into the designation and run the test to the designation. You understand? So also it gives you information on what the colors are. So in some people would just have this as being purple, but it's actually violet. So pay attention to colors. This look more like orange more than red to me, but them says red. So you understand? Pay attention to colors. The band, if they have bands, and another thing to pay attention to if you happen to have to join anywhere is wire size. Remember, wire size affects, wire length and size affect resistance. And resistance do what the current opposes the flow of current. This no, I'm too far down. Right? Okay. It's the only thing I need. Yeah. All right, so junction block connection code. And this is very important. Because now here we are with a whole heap of different junction within the car. So as I said before, we have to collect the information. It's important that we collect the information and we know how to interpret the information. So we can make good use of the information. Right? So indicating the color code for a connector are connected in the junction block. Int refer to the location route for the shape. All right. So here we are now. We're looking at junction block 3B. And within junction block 3B, we have A, B, C, and D. Right? Also E. E is separate and apart from this junction. Right? So A represent the inner circuit of the junction block. So the arrow pointing down. The inner circuit of the junction box. B indicate the junction box color code, junction box code number, sorry. Right? It represents the junction box code number. That's B. And C indicates the sequence code of the connector which belong to the junction box. D indicates the terminal number. So it will tell you that in B3, terminal 4, right? Or terminal 5. And E, if there's only a number inside, it indicates that this is the relay block, fuse block, or others. So I know this might be a lot of information all at once, but if you are able to go back through with a good diagram, then you can begin to exercise some of these, practice some of these what we have getting, that we've been getting. All right. Go down here. We want that come up in the camera, can't see. Which one? All right, so it's also important now as we do, we go through the junction and all these things to find the ground points, right? And grounding is very, very important. Just the same as if you were to apply a power source. Remember this, if we are unable to close the loop, then we won't be able to have operation of the load. Right? So this refer to location and routing of for the locations, right? Different ground location. So A here indicates a wire harness which is connected to the ground point, and B, an alphabet code is used to distinguish the ground point. For example, MJ indicates that the wire M is connected to point J. So there we go again. It's just collecting the information and what we do with the information, how we understand the information, how we interpret the information. If we are unable to interpret the information, then we're not going to be able to make a positive contribution. Okay. Yeah. All right. So wiring connection code. This indicates the code for the connection which are used to join two wire harnesses. And this refers to the list for the shape of the connection. Thank you. Thank you. Wires and wire connection. A indicates the terminal number. And we said terminal, we mean the terminal that's connected to inside the junction, whatever the junction point is. Right? B indicate the wire harness which is connected. For example, FH indicate the connector joint indicate that connector F, the female connector, 1, and H, the male connector, 2 of 2-wire harness. So 1 is female connector terminal and 2 is the male connector. That's very, very important information because 9 out of 10 times, where is the male connect? Where is the male part of the connector connected to? Anybody can guess that? Hello?
Can you
Anybody
repeat?
can guess me that one? I give you a Christmas present for that.
Repeat that again.
So we have number 2 in B indicates wire and harness which are connected. For example, if H is connected to connected F, the female connector, 1, and H, the male connector, 2, to 2-wire harnesses. And it says the female is 1 and the male is 2. And I'm asking you now, what is the male side of the harness generally connects to?
Is it to the relay?
The load. Very good.
Load.
Very good. It's all 9 out of 10 chance. More than likely, if you see the female connecting to a load, it's somebody else connect that. So we don't know about things.
Okay.
Right? So the male is generally connected to the load. So if, for instance, you are to take a fan motor, you notice the male is always to the motor and the female is to the loom.
Right.
Yes. Just like with a coil, it's the same. Just like with any load, it's the same. The male is to the load, to the component. All right. So it says C's indicate the sequence of numbers connector used for the same combination of the wire and harness. And D indicate that the male is connected. Yeah, never genius in the mix. So here we have I, right, which is the terminal number. And we have J as a part name and connector code. So the terminal number indicates the terminal number of the connector which is connected. Because you know, you may have pre-wire junction and connectors. They are just pre-wired within the vehicle, but they are not functioning. Right? So just in case something were to be added to the vehicle, then you wouldn't have to change the loom. It would already be there. You get that?
Yeah.
Yes, sir. I see that in the Suzuki.
Yeah. So in most vehicles, you will have things pre-wired. Right? I would say if we work on different vehicles, you will see a lot of stuff that are pre-wired. Like I said, if something else needs to be added, then you won't have to change the loop. You just add it to the circuit and you're good. All right, so J, part name and color connection indicates the part name of the code for the connector which is connected to the part. All right, so we speak about the terminal number that's connected to which is connected, and the connector that is connected to the parts. All right, so look here, now this something like it want to fix to me. So G25 is what? Shift lock control E. All right, so the shift lock control E. Now you see it's A and B. And for the power management control, you'll have C and D respectively. All right, so 2 indicates, sorry, A indicates the harness which is connected belongs. For example, G indicates the connector is used on wire G. Refer to the location and routing for the wire harness named for wire G. B indicates the sequential number of the connector which belong to the harness. And C is the connector code. Right? And now D distinguish the connector when there are multiple numbers of connector connected to the parts, when there are multiple type of connector for different specifications. Right, so those are just all information for the different designations. All right, so location and routing indicate where the wire harness connect, and ground points are located in each vehicle section, such as the engine compartment, instrument panel. Also indicate the location of relay and relay blocks. All right, so relay blocks is RB, antennas, ECU, etc. Along with inner circuit as the relay location in which the vehicle section. In each vehicle section. Location indicates where the wire harness and connectors are located for each vehicle section. Also indicate the ground point of each connector code. The connector code is the same as the code used in the system circuit. Okay, so this is pretty much the look and the arrangement of what we're talking about earlier. So it gives you the designation, it gives you colors to identify the part and where they end up at different locations. Right? So this is a lot of mumbo jumbo right now. But if you can pinpoint the different section, then you will see that it's really highly beneficial. You understand? Okay, so this is tell you that this as a particular fuel type. So if we look and some of the components then within this, we can tell that the vehicle is okay. So it has an ECM for petrol and one for diesel. So I guess that's depends on the cross branding, wherever the market is. So it's application for both. Just like how you would have the pre-wire. So if it's petrol, that would be the location of the ECU, and if it's diesel, that would be the position, the designation, the location, sorry, of the ECU, right? So you have the engine room junction 1, junction block number 1, and then you have the fusible link block assembly. You have the skid control ECU with actuator assembly for right-hand drive, and for left-hand drive, it's at a different location. So it's at the wheel well, and for the right-hand drive, it's on the left-hand side if you're sitting in the vehicle. And for the left-hand drive, if you're sitting in the vehicle, it's on the right-hand side. Also, you can see engine room junction block number 2, and it's the engine room number 2 junction. And we can also see that we have the glow plug relay. Right, so this anti-skid control unit is the same thing as the ABS module. Okay, so what we are seeing now is from some of all of that information that we're talking about, connectors and the terminal numbers, right? From connectors to the terminal numbers. Yeah. Yeah, so we're seeing. All right, so this is not a very good picture, but so like this now would have a color to this connector, right? Whether it be gray, white, blue, whatever. It will tell you the amount of pin that is within the connector, right? And it will give you letters and numbers as designation within this connector. So for each of these connectors, they will have different characteristics in terms of color, arrangement, number of pins, number of terminals, color wires, and such forth. Right? So there's 1,000 information inside of this. What you need to do is just pay attention to the problem area and don't get confused by all of this. So if we are dealing with the junction or the connector that's supposed to be white, don't look on the gray one. All the information that you want is in the white one. Right now, you may have more than one white one within the area. So this is where the numbers is important. The numbers with the letters. Remember, we had shown you that 3B, and then we give you the different designations. You understand? So that is where that comes in important. All right, care about them. Sorry. All right, so you remember now we had said that when you go on the diagram, the first thing you want to do, if we don't know, is learn how to use the diagram. All right? Until we know that, then we can begin to practice what we know. So A connector number indicates the code for a connection or for a connector which is connected to the junction block. B speak to the number of terminal, right? And it indicates the code for a connector which is connected to junction block and also terminal. Remember we said it depends on the color, the amount of pin, right? And the color and the number and the letter to identify the connector. Right? Also, we can look at the shape. Right? So you have connector shape and terminal. This indicates the shape of the connector and the RNS size and number indicating the terminal number. And D connect shape and terminal number. And this indicates the shape on the connector of the junction block. So I just want to bring you back to one specific connector that I'd seen. It looked very, very weird. I've never seen anything like that. So I want to show you that they just have different size. I'm trying to find it here and see if you will agree with me. I think this is it. Oh no, that's not it. Oh, this is it. Bring it up a little for me. Let me show you. All right, stop right here. Go for this. Look at this connector. It looks like it's a man's head. So if you're looking for this connector, you can't lose it, you know. As you look out, it step out at you. Eh? If anybody never know Mr. Basic, you look at this, you see Mr. Basic. Yeah? So it is important that we pay attention to all information. You understand? Anyway, guys, it was a pleasure. We'll catch up with this on Thursday. And gear up yourself, like I said. If you get the information and you don't use it, you certainly will use it.
So true.
Yeah. So we want to get on with it. Mr. Basic will take you out.
Thank you, sir.
Thank you, sir.
Evening, everybody.
Evening.
Mr. Beswick.
Yes, I'm listening.
Mr. Ellis.
I can barely hear your voice.
Come on, Mr. Ellis, Ricardo.
Oh, Mr. Ellis, how you doing, Mr. Ellis?
Doing well.
Yeah, good night, everybody. Sorry I didn't get to do a proper introduction, Mr. Scott. Some of you already know Mr. Scott. He's very good at diagnostics and electronics and that kind of stuff. He's very capable of leading this section here that has to do with electrical and a degree of electronics as it relates to wiring. The exam does not go this deep, but we still wanted to have a good foundation understanding of how basic electrical and some electronics work. So you get the principle move into another level. So I just hope that this session was very informative. If there are any challenges, some points you wanted to make, some concerns, going too fast, whatever it is, something you need clearing up, just put it in the group and we try to address them before the start of the next session. And so we can have everybody on one page. Electrical is not, it's a specialized area and it's not something you can just take up today and put on tomorrow. You have to do a lot of reading and research. It's like a language by itself. So you have to understand the techniques very well so you can do the troubleshooting properly. So I know sometimes you might be saying some things that is a little challenging, but it's not going to get really much simpler than that. You know, maybe we can try to simulate a situation or something to explain it a little simpler, but the truth of the matter is that sometimes we need to do some extra research so that this information can come clearer. All right. So again, I want to thank you all for your time and the sacrifice. Please remember to do your studies. We done a lot of past paper revision. Hope you remember those things that Mr. James went through with you. Those things are very important. Don't wait until the last minute, as Mr. Scott said. You don't use it, you lose it. You don't make an effort to remember, you're going to forget. All right. The exam is not hard, but it's not a pushover. Remember to bear in mind that date. Also, there is a number that is on that WhatsApp that I send you. It's an enrollment number. Don't forget that. And the key codes, those numbers. So if you want to make sure you have a picture of that on your phone so that when you enter the exam room, you can punch in those numbers on the computer so they can identify you so you can do the test. All right, so make sure you have the number written down somewhere, or it's on your phone. You're not allowed to use a phone in exam. So I'd prefer if you wrote it down on something that you can remember, that you can make reference to it for the exam. All
So,
right.
Sir Beswick, everybody will be doing exam at 8:30 on the 11th.
Now we're gonna shift it up. By the time by next week we should be decided. You see, I wasn't sure of how many persons were going to register at the time, so I couldn't get to make that decision. But I'll
Okay.
make it by the end of the week or beginning of next week. So as
Okay.
to who are coming from 9 or 8:30 to 10 or and from 10 to 1, that kind of thing. So too many persons are not in the exam at the same time.
Okay.
Right? So we'll make that decision later on. All right. But in the
And
meantime,
you send me the location, right?
yes, it says, well, yes, I can put it in the group. It's 32 Hope Road.
Okay.
32 Hope Road. That's just a little further up from, but on the other side from Andrews Hospital. I can't miss it.
Okay.
There's a name out there called Liberty Academy. It's just on the same compound. Yeah.
All right.
Yeah, man. So all the best, gentlemen. Thanks again for joining and the sacrifice that you have made to be here every night, and God go with you. Until next time.
Likewise.
Okay. Cool.
Bye.
Good night. Somebody asked a question. What do you want this one?